So you get metal first, and then you get like 4H2O. This is 4, this is 4, and it is balanced. Now let's see if let's look at the first question. That is, what if you have like 12 atoms of iron? Like, how many iron oxide molecules do you expect to have? So this is kind of intuitive, right? Because, you know, like the coefficient for iron is like 3 iron, and then like the molecules, like for every 3 iron atoms, there's like only 1 iron oxide molecule. And that's exactly why when you got 12 iron atoms, you would expect like 3 times 4 equals to 12, right? So you time it by 4, it's like 4 iron oxide molecules. And that's exactly how you deal with stoichiometry.
Let's introduce the concept of mole bridge. So ultimately, mole bridge serves the purpose of like transferring different units into other measures. For instance, if we know particles, like how many particles we have, how much volume of such substances we have, or like the mass of the substance, we can use the mole concept or like the mole bridge to transfer the measure into other measures. So like the standard units, for instance, like Avogadro's number, like STP, ACTP, for instance, like 22.7 liters per mole, or even molar mass of the substance. So let's dive into the concrete example of this. For instance, the same example of like iron's reaction with water. So with the given question, like with 200.0 grams of iron oxide, how much water molecules are involved in the reaction as reactants? So let's think about this. So this is like the mass we have. We know the molar mass of iron oxide is 232 grams per mole. And then with the given mass, we can transfer it through the mole bridge into other measures. For instance, the molecules, which is particles. So let's write down the equation. And then we use the coefficient. We know like the exact ratio between these molecules, and then we adapt it. We know for every 4 mole of water, of 1 mole of iron oxide. And then we use Avogadro's number, which is 6.02 times 10 to the power 23 molex over 1 mole. And we get the answer. Remember, like the sig fix. So the answer is 20.82 times 10 to the power 3 water molex.